twice.
So, in college algebra,
Oh,
you learned how to find the horizontal, well,
Asymptote.
yeah,
Oh,
horizontal asymptote in college algebra. It changes in AP calculus, but we're just gonna review it because on the AP test, sometimes they revert back to college algebra. 3 scenarios in defining the horizontal asymptote in college algebra. If they ask you to find the horizontal asymptote, you take the highest power in the numerator and divide it by the highest power in the denominator. That was what you learned in college algebra. That's not what we're doing in AP calculus, but I'm showing this anyway because I've seen this on the AP test. So the highest power is 3x squared, correct, you guys? And the highest power is 5x squared. The x squares cancel out, 3/5. Horizontal asymptote starts with the letter y, right? So y is equal to 3/5. If I graph this, but I'm not gonna do it. If I graph 3x squared plus 5x divided by 5x squared plus 7x, there should be a horizontal asymptote at 3/5, which means you get closer and closer and closer to 3/5, but you can touch it. I'll talk about that later, but good to go? Okay, now, 3 different scenarios, because as you can notice, these two, or the first one, there's the exact same power on the top and the bottom. This one, you take the highest power in the numerator and divide it by the highest power in the denominator. And this is what you want to do to find the horizontal asymptote. I'm going to go back to number 1. As x is getting bigger and bigger, if x was 10, it'd be 100. It'd be 300 over 500, which would still be 3/5, correct? If x was 1,000 squared times 3 and 1,000 squared times 5, wouldn't that still make 3/5? Okay, so that's what you're doing. You're putting in like a very large number for x. What happens if you put a very large number for x here, a number in there and a number there? Wouldn't this be always way bigger than that one?
Yeah.
So a smaller number divided by a bigger number is going to get closer and closer and closer to what? A smaller number divided by a bigger number. Let's try it. X is 10. 30 over 200?
Yeah.
3/20. Okay, let's put 100 in there instead. That's going to be 300 over 20,000. What is that getting closer and closer to?
Where's 0?
0. Yep. Y equals 0. The denominator is going that much faster than the numerator, right? So it's getting closer and closer to 0. This one, what happens if the power on the top is higher than the power on the bottom? If x is 10, it'd be 200 over 50. The top is getting really big, and instead of dividing by the smaller number, there is no limit because this is always getting bigger, right? Right?
Yeah.
So this one has no horizontal asymptote. So, let's look at the scenarios again. If the powers are exactly the same, then you can easily tell what is the horizontal asymptote, correct? If the power on the bottom is bigger than the power on the top, it's always going to go to what number? 0. If the power on the top is bigger than the power on the bottom, there's going to be no horizontal asymptote, and that's what you learned in college algebra. Now, how do you do vertical asymptotes? Vertical asymptotes, all you do is x minus 2, x is equal to 2. That means it can't equal 2, really. That's the vertical asymptote here. What happens if you put 2 in there? You get 0 in the denominator. You can't have it, so that's why there's an asymptote right there, right? If you graphed 1 over x minus 2, it would look like like that. See that? There's a vertical asymptote at 2. There's 2 vertical asymptotes on this one. There's one at x equals 2 and the other one at x equals 1. So if you have the time, graph these to show. The graphing calculator does not put a dotted line in there. Your graphing calculator just does this. You have to be able to, like, you know, put a line in there to show that there's a vertical asymptote at 2, right? So how do you find the vertical asymptote in algebra? You set the denominator equal to 0, and that's what it can't be, right? That's what x can't be, because if it was that, it'd make 0 in the denominator. That's why it's called an asymptote. You might not know this, but horizontal asymptotes you can cross over. Vertical asymptotes you cannot ever cross over. There are problems in math that you can cross over horizontal asymptotes. So, okay, moving on. Okay, now comes the calculus version of a horizontal asymptote. So you already know the college algebra version of an asymptote. This is a horizontal, this is the formula. So make sure you know this formula. So let's read it here. The limit of some function, correct? We don't know what the shape looks like, but it's some graph, correct? The limit of some function as x is getting bigger and bigger and bigger gets closer and closer to some number. Or if the limit of f of x as x is approaching a negative infinity gets closer and closer to that number. Then there is a horizontal asymptote at y equals b. Got that? Okay, so for example, if the function as x is getting bigger and bigger gets closer and closer to 3, and this one also gets closer and closer to 3, then there's a horizontal asymptote at y equals 3. Okay, here's another scenario. The limit of f of x as x approaches infinity equals 3, but as you're approaching a negative infinity equals a negative 3. Then there's a horizontal asymptote at y equals 3 and y equals a negative 3. You have 2 horizontal asymptotes, right? You have one at 3 and you have one at what number? A negative 3. So keep in mind that you can have no horizontal asymptote, 1 horizontal asymptote if these numbers are the what? The same. Or you could have 2 horizontal asymptotes if these numbers are what? Different, right? If they're different, you're going to have 2 horizontal asymptotes, right? So keep that in mind. Everybody got that? So this B, I mean, you could put a 3 here and you could put a 3 here and you could say y equals 3 for one scenario. I might as well put it. This could be a 3. Oh, it's, where is it? This could be a 3, this could be a negative 3, but then you could have y equals 3 or y equals a negative 3, right? Those are the types of scenarios that you could have, so. Okay, next. So, let's go back and revisit. Let's look at this one first. Oh, we're doing red, I guess. That's okay. Look at y is equal to 1 over x. There it is. And there it is. Okay, and we're going to say the limit as x approaches infinity, or the limit as x approaches a negative infinity. And this is the function f of x. Could it just change? Is it just fun? Okay, yesterday, the limit as x approached a number yesterday, right? Approached 3, approached 4, right? Now we're approaching infinity. So look at x, and you're going to a very, very, very big number, right? Or isn't this the x-axis? Isn't this 1, 2, 3, 4, 5? What happens as x is approaching a big number? What is this line getting closer and closer and closer to? What's the y value? Yeah, 0. The limit of f of x as x is getting smaller and smaller, what's the limit getting closer and closer and closer to? 0. There must be, what the heck? There must be a horizontal asymptote, aha, at y equals 0. It makes it fun.
That looks great.
Do you like that? Yeah. There must be a horizontal asymptote at y equals 0 there, and the problem there is, isn't there, you guys? Yeah. Okay, let's do another horizontal asymptote. Let's do this one. Let's revisit the sine of x over x again. Do you guys remember what he looked like? He looked like it went and then it went like that, right? Something like that. Alright, kind of went like that. We looked at as x approaches 0. Do you guys remember doing x approaches 0 and it got closer and closer to 1? Do you guys remember that? Now we're looking as x approaches infinity. As x is approaching infinity. As x is getting smaller and smaller and smaller, it looks like this, but it's not the best. But it looks like this. And then, do you see what's it doing, you guys? Isn't it like flattening out? And it's getting closer and closer and closer to what number? The 0. Yeah. It's getting closer and closer to 0. It flattens out. Do you see that this is a horizontal asymptote and you're actually crossing over the horizontal asymptote? But you are getting closer and closer and closer to 0. So, okay, let's do these here. Let's do this one. The limit as x approaches infinity of 5x over x plus the sine of x over x. You can do this one by graphing, but this might not be a graphing one on the AP test. You can split it up into the 5x over the x plus the sine of x over the x.
Just randomly switches.
Just randomly.
I'm trying to watch the color
Oh boy. Zero in on the 5x over the x plus the sine of x over the x as x approaches infinity, right? So, we know that this is the octopus, right? And we know that if it gets bigger and bigger and bigger, it's getting closer and closer to 1 or 0. It's getting closer and closer to 0 for that one, right? What happens to these x's? They cancel out. So what is this one getting closer and closer to? 5. What's 5 plus 0? 5. If we graph this, there should be a horizontal asymptote at y equals 5. But don't just put 5 down. Make sure you put y equals 5. Horizontal asymptotes have y equals 5. I'm going to try to do it fast. I'm going to try to show this to you. What is it? 5x plus the sine of x divided by x. Oh, that's kind of cool. This is what it looks like, you guys. See how it's kind of flattening out to the 5 way up there? Do you see how it's flattening out to the 5? See? You two, do you see? It kind of looks like the other one, but it's definitely flattening out to a 5. And as you get bigger and bigger, it's flattening out to a 5. So, okay, moving on. This one. F of x is equal to x over the square root of x squared plus 1. And I'm just going to hurry up because I wanna get done with these notes today. I'm gonna show you what this graph looks like, but if you wanna take the time and do it tonight and graph it on your own, you can. But it looks something like this. And it looks like this, and it looks like that. There's no dotted line though on your graphing calculator. There's no dotted line. It just, you have to notice that this is getting, as x is getting bigger and bigger, your x value or your y value is getting closer and closer to what?
1.
1. And this one, as x is getting closer and closer to a negative infinity, well, this direction is a negative infinity, then the y value is getting closer to a
-1.
-1. Do you see that these two are different numbers? So that means you have two, what? Horizontal asymptotes. You have one at y equals 1, and you have one at y equals a -1. And there you go. Okay, now the next one is, I think we just did this one. We just did this one. Just a review. Okay, this is review. Okay, so now this is from 2.1. I don't know why I'm throwing this in here, but I'm going back to 2.1. We have been studying as x is approaching infinity. Now we're going back to 2.1 and going back to x as x approaches 0. And let's see if you guys know, if we break this up, it's x over x plus the sine of x over x, correct? X divided by x is 1, isn't it? Plus, I tell you to memorize the sine of x over x, that's the octopus, right? As x is getting closer to 0, what's the intended y value? 1, right? It's not going to infinity, that's 0, but when it's going to 0, it is 1, if you think of that picture, right? So the answer to this problem is 2. You have to know what your x value is going to. And it all depends. Does everybody understand that problem? Everybody got it? Yep. Okay, let's do this one. That's algebraically, that's showing your work algebraically. We're gonna do this one graphically. And again, just to go a little faster, if you plugged in x divided by the absolute value of x, it looks like this. This is 1, and this is a -1. That's what x divided by the absolute value of x looks like. And then some of you already might do the answer and been just waiting for me, or some of you are just gonna wait for me to do it. What's the limit as x is approaching 0? What does this little negative sign tell you to do? From the left. So you're approaching 0. Well, this is 0, and you're approaching it from the left side. The intended y value is -1. Is there a different answer if you're approaching 0 from the right? Yes. Good to go? I think you guys are definitely understanding limits, so that's good. Okay, moving on. What's a vertical asymptote now? So a vertical asymptote is if your approach as the limit of some f of x, that's supposed to have a little f of x there, I forgot about it. The limit of f of x as x is approaching some number from the left or some number from the right doesn't equal a number, but it equals an infinity sign. There's a vertical asymptote. See the difference between it? Horizontal asymptote, x is approaching infinity, makes a number. Vertical asymptotes, you're approaching a number and it makes infinity. Do you see the difference between a vertical and a horizontal asymptote? So let's go back to the same exact graph that we just did. This is a beautiful graph because this really teaches you. I'm going to do the ha on here and I'm going to do the va on here both. I know we already did the ha, but you'll understand, hopefully you understand it then. This is f of x, and you guys know that this is 1 over x, but that's okay. The limit, as x approaches, when you're doing horizontal asymptote, this needs to be in an infinity, or the limit as x approaches a negative infinity of your f of x of your f of x. The definition of a horizontal asymptote says that you're going to infinity or a negative infinity. And we already did this, but we're going to do it again just so that you understand the difference between the terminology of a horizontal asymptote and a vertical asymptote. Are you guys there? So as you're approaching infinity, as x is getting bigger and bigger and bigger and bigger, the y value is getting closer and closer to 0, which we already said. As x is getting smaller and smaller and smaller, which is right here, you're getting closer and closer to 0. This one only has one horizontal asymptote because these numbers are exactly the same. So there is only one horizontal asymptote at y equals 0. Do we understand that? If there would have been two different numbers, you would have had two different horizontal asymptotes. Now, we haven't done a vertical asymptote terminology, and this is what it looks like. The limit, as x approaches, this is f of x, and the limit as x approaches 0 from the right and 0 from the left. You're approaching 0 from the right and 0 from the left. Okay, let's go back to the vertical asymptote. See the terminology of the vertical asymptote? You're approaching a number, your answer is going to be in an infinity or a negative infinity. Do you see the difference? See the difference between it? So let's go back and see. You're approaching 0 from the right. Here's 0, here's the road from the right. And as you're approaching 0 from the right, the y values are going to where? Infinity. You get an infinite answer, and as you're getting closer and closer from 0 from the left, your car is getting closer and closer to the y values, but they keep getting a negative infinity. And basically, infinity and negative infinity, you have a vertical asymptote then at what number? At 0. So you have a vertical asymptote at x equals 0. See the difference between it? Horizontal, you're going to infinity, you get a number, you get an infinity, which makes sense. So I think you guys I think I'm pretty clear on that for you guys. Good? Okay, we're moving on. You're doing good. Okay, right end and left end behaviors are next. Okay, this is kind of confusing, but this is really weird. So the end behaviors, you guys, back in your day, I'm just going to go over here, and they're changing it a little bit, like a parabola. The parabola end behaviors are, it starts up and it ends up. Do you guys remember those end behaviors? Okay, so I'm just going to do one more. A snake that looks like this starts down and ends up. Those are called the end behaviors. So in part 3, they're asking you about the end behavior. The right end behavior, just make sure you're looking. We're going to do that. At the right side of your graph. The left end behavior, make sure you're looking on the left side. of your graph. This is a little bit different than what you learned in algebra. You learned that they can either be both up, one down, one up, both down, and one up and one down, correct? But this is a little bit different. It's not that much different, but this is kind of weird, but we're going to do one right here. This one right here. They're going to ask you to find the right end behavior and the left end behavior for x plus e to the negative x, which you've never seen before. So, you're going to look at the graph. I like that. So everybody graph this really quickly. Let's see. Under y1, you're going to put in x plus e to the negative x. X plus e to the negative x. The e is above the natural log button, right? Under y2 and under y3, under y2 you're going to break these both up, and you're going to make y2 just the x, and you're going to make y3 just the e to the negative x. X and e to the negative x. And you're going to hit graph. Mine's in color, which is so fun.
So much better.
I'm just going to show, yeah, it's really nice. Okay, I'm going to show you in color exactly what my graph did. So, this is so cool. My first one came in blue. I don't know what color, maybe you don't even have a one, but mine came in like this. That's my blue one. That was the original one. And then the red one came in. Y equals x. I think a lot of you know what y equals x looks like. It's a diagonal line that goes through 0, 0, and it comes in like that. Whoa, it's supposed to be red. And then the last color is black. And a lot of you know what an exponential function looks like. It looks like, oh jeez.
The colors don't like this, right?
No, I'm not even thinking, that's why. And that's what the third one's coming in. And again, color doesn't really make a difference. Okay, so you're supposed to look at the graph and figure out what the right end behavior looks like. Well, here's the right side of the graph, correct? Well, the original one is in blue. Can you see the one in blue? This is that one. Which one of these two is the same direction that the right end is doing? The red one, the black one down here is definitely not doing what the blue one's doing. It's the red one that's doing almost identical to what the actual blue one is doing, and the red one is y equals x. So its right end behavior is the x part of the graph, and the left end behavior, I think you guys get the idea. The left end behavior, again, the blue one is the actual answer, and the y to the third is the black one, and the black one and the blue one are definitely very similar to each other, so that would be the left end looking like, which would be e to the negative x. This is totally different than what we learned in algebra class. So here's another one, because I know they do this in the book. Does everybody understand that? That's kind of fun how it's doing that. But you're going to get a function, and in this one there was only two, correct? There was an x and an e to the negative x that made up the whole function. There might be, under y1, there might be 1, 2, 3 different functions, you know what I mean? And then under y2 would be this one, would be that one, and then y3 would be the middle one, and y4 would be the last one, you know what I mean? Because this one only had 2, so it was pretty easy to tell the right and the left, because there's only 2. There might be 3, and this one is going to be the blue one, which is the actual one, and maybe the last one looks more like the right hand side of the blue one. So maybe this one is the right one, and maybe the Y3 is the left one, and maybe the first one doesn't look like either, you know what I'm talking about? So that's all you have to do. You get all that? Okay, so. Okay, moving on. Everybody got that? I think they did. I can do that. Okay.
Yeah, that was good.
Another, oh boy, here we go to the next page. It's not. We got 4 pages. Maybe finish. Another easy way to find the ha and the va. We're going back to college algebra. We're not going to do the limit. I mean, you could do the limit, but I'm not. I'm going to do that shortcut. To find the ha, you take the highest power in the numerator and divide it by the highest power in the denominator to find the ha. So the ha in this problem is y equals 3. To find the va is the vertical asymptote. What can't x be in the denominator? X can't equal 0, so there should be a vertical asymptote at x equals 0. I don't know why we're doing it again, but we're doing it again. I'm going to do the va first. The va is what x can't be. X can't be 2, right? X can't be 2, which would make it x equals 2. Try to explain that to an Algebra 1 kid, that it can't be 2, but the equation is x equals 2 because it's a vertical line, right? And the horizontal asymptote, take the highest power in the numerator and divide it by the highest power in the denominator. And as x is getting bigger and bigger and bigger, 3 divided by 20, 3 divided by 200, 3 divided by 2,000, it's getting closer and closer and closer to y equals 0, right? Okay, moving along. We are 3 to go. Use graphs and tables to find, and it's way down there, which I didn't know it because it's way down there. The limit of f of x as x approaches infinity, a negative infinity, identify any horizontal asymptotes. And here's the equation that I should have put it way back up at the top, but it's way down at the bottom. Again, if you had time, you could graph this, but I want to make sure I get done with these notes because this is getting recorded right now. So, up 3 and down 3, and if you put this on your graphing calculator tonight, it looks like that. And I'm not going to even put the dotted lines in there because on your graphing calculator, $120 calculator, they don't put the dotted lines in there. So you kind of know that it looks like a sideways snake, correct? So let's figure out the limit of f of x, which is that function down there. As x is getting bigger and bigger and bigger, your y value is getting closer and closer to what number? 3. Everybody see that it's 3? And as your x is getting smaller and smaller, your y value is getting closer and closer to negative 3. Identify any horizontal asymptotes. You have 2 of them, correct? You have one at y equals 3, and you have one at y equals a negative 3. You can have no horizontal asymptotes, you can have one, or you can have none. So, I mean, a diagonal line. There is no horizontal asymptote on a diagonal line. So, okay. 2 left. Part 5. The limit as x approaches 2 from the right, 1 over x minus 2. Again, I'll just tell you what the graph looks like. On the test, show me what the graph looks like. But at 2, we have a vertical asymptote. You guys know that we have a vertical asymptote. and it looks like this, and it looks like this. What's the limit as x is approaching 2 plus? You're getting closer and closer and closer to what? You're approaching x from the, or you're approaching 2 from the right side. Your y value is getting closer and closer to infinity. And if it's getting closer and closer to an infinity or a negative infinity, there must be a what there. If your answer is infinity or a negative infinity, there must be a vertical asymptote there, right? So I'm not going to say that, but you know that, so that's good. Okay, this one. Oh, we have to graph this one together. This one's fun. We have to do this one. Okay, so go back to y, clear. Maybe not your fun and my fun are not the same thing. But. Okay, do alpha f1 so that we get a fraction bar, correct? I know that there's an x on the bottom, but what's that weird int x? Well, go under math, and I think it's under numbers. Yep, go under math, and then arrow over to numbers, and it's the fifth one down, and it says int. Everybody see that? Under math, arrow over to numbers, and the fifth one down says int. Int x. Wait till you see what this graph looks like, you guys. You're not in Kansas anymore. I know.
That's sick.
I know, isn't that the weirdest graph you've ever seen? I tried to copy it last year. This is my version of what it looks like.
First sound effects to go with it.
Feel like that? Yeah. Okay, so as x is approaching 0 from the right, you guys. You're approaching 0 from the right. Well, isn't this the right side of 0? Can you tell what the intended y value is by looking at your beautiful graph that's sitting there? No. So you need to resort to looking at the table also, because this isn't clear enough. That one that went from 3 to a negative 3 was really easy to tell. This one is not easy to tell. So go to second table set. You want to start at 0, correct? Start at 0. And let's count by 0.001, because that's pretty close to 0, isn't it? Isn't that pretty close to 0? You could even go more, 0.00001, but 0.001, second table. Ooh, I love this one. Look at that. Okay. Are you looking at the table?
Ooh.
At 0, there's an error, correct? On the right side of 0 is 0.001, and on the left side of 0 is a negative 0.001, correct? So, but we're looking at 0 from the right side, and the right side, they're all the same number, thank goodness, right? The answer is 0, yeah.
But if it was from the left side?
I don't know, you'd have to pick it apart even more.
Yikes.
I think it's,
That sounds weird.
to me, I think it's gonna go to infinity, because it goes from 333 to 500 to 1,000, correct?
Yeah.
I bet if I did 0.00001, that number would even be bigger.
Probably.
I think it's going to infinity. See how you have to play around with it? On the left side, I think it's going to infinity. On the right side, it's going to 0. You can't
Let's
just,
try it.
don't put 1,000 down on the test because your calculator said 1,000. You have to go out even more, 0.00001. You know what I'm talking about? I bet if you check it, I bet it is. I'm not 100%, but I'm pretty close that it's a, what happens when you did a 0.00001 or something like that?
A lot.
Okay, so it's infinity, I'm sure. I'm sure.
Negative.
Negative?
No, so. Hold on. So.
I'm shocked that it's.
Negative 1e to the negative 8 is 1e8.
Yeah. Okay. Which
Yeah,
is.
it just
Which
keeps
is
getting
ridiculous.
Okay, that's big. I thought you were
Yeah.
talking. Yeah, it's very big, which is infinity.
Yeah.
Okay, last problem of the day, you guys. This is very important. This is on the test. Oh, we got lots of time. We are doing great.
Oh, where'd you go? Oh, really?
1 over x squared minus 4.
We'll actually have time to wash desks.
1 over x squared minus 4. Again, I'm going to show you what the picture looks like. If we had a lot of time, we could all sit and graph these, but we just don't have a lot of time. This is x minus 2 and this is x plus 2. There's a vertical asymptote at a positive 2 and a negative 2. Right here and here. I just wish they would put the dotted line on here, but they don't. It goes like this on your calculator, this on your calculator, and this on your calculator. You have to eyeball it and go, oh, there's one right there, you guys. Do you see it? And then there's another one right there, but they're not going to put the dotted line in. They should. Like I said, $120 calculator, why can't they put the dotted lines in there? But so, they want you to find the vertical asymptotes. Well, vertical asymptote starts with the letter x. Don't forget the letter x on the test. X equals 2 and negative 2 is there. It's a vertical asymptote. You could just do plus or minus 2 if you want to. And if you want, you could actually, when you want to draw them in there, you might as well put them in there. Describe the end behavior to the right and left of each vertical asymptote. So this is what I want you to do on the test, so watch carefully. Describe the end behavior to the right and left of each vertical asymptote. Different end behaviors than what I was doing with that, breaking that up. This is what I want you to do. The limit as x approaches 2 from the right, and the limit as x approaches 2 from the left, your f of x. You have another vertical asymptote as the limit as x approaches a negative 2 from the right, f of x, and the limit as x approaches a negative 2 from the left of your f of x. Describe the end behavior to the right and left of each of the vertical asymptotes. Well, they want the right and the left, so you need to use a positive and a negative sign to show that I'm doing the right and the left at that vertical asymptote, and the right and the left of that vertical asymptote. Got that? Okay, you guys ready to fill in these 4? And then we're done. We got 5 minutes, not even. 2 from the right. 2 from the right. Here's 2. And you're approaching 2 from the right. What's the intended y value? Infinity. What about 2 from the left? Negative infinity. Good? Okay, negative 2 from the right, you guys. Let's see.
Negative infinity.
Yep. Here's a negative 2. This is the right side of a negative 2. It's getting closer and closer to a negative infinity. And I don't look, but I think it's positive infinity, isn't it? I don't want to scroll back up, but I think that one's also positive infinity. So, okay, I think we are done.
There's no technologies.
Mm-hmm. Let me just...
Little late again today?
Yes.